Have you ever wondered how computers talk to each other? In networking, communication doesn't just happen randomly, it follows a set of protocols and rules to make sure every message gets through correctly. Simply put, it is how they are encoded, formatted, scaled, timed, and delivered. Good day everyone, I'm Cajipe, a student of BSCS3IS, here to break down each rule and show how they work in Cisco Packet Tracer as we go. First, there's message encoding. This is how data is converted into signals that can travel through cables or wirelessly. In Packet Tracer, you can see this. When a PC sends a message, it turns digital data into electrical, light, or radio signals depending on the medium used. Next is message formatting and encapsulation. This process defines how data is structured before it's transmitted. When a message travels across a network, it passes through multiple layers. Each layer adds its own header and sometimes a trailer, wrapping the data like layers of an envelope. This ensures that the message reaches the right destination and can be reassembled correctly. In Packet Tracer, you can visualize this by switching to simulation mode. When a packet is sent, you can click on it to see these encapsulation details, and will notice how each layer adds its own information as the packet moves from one device to another. Then, we have message size. Each network limits how big a packet can be. This is known as the maximum transmission unit. If a packet exceeds that limit, it's broken down into smaller segments so it can be sent efficiently. In Packet Tracer, this happens automatically when simulating file transfers between devices. Next, we have message timing. This rule controls when data is sent and how fast it moves. It prevents network congestion and ensures that devices take turns sending data. It also keeps communication synchronized so that no device gets overwhelmed. In Packet Tracer, you can see timing in action by connecting multiple devices through a hub or switch. See how I'm sending several packets at once? And notice how timing affects collisions or smooth data flow. Essentially, the packets are giving way for one another, as shown here. Finally, message delivery options decide where the data goes. Unicast for one device, multicast for a selected group, and broadcast for everyone on the network. For instance, when you send a file directly to another computer, that's unicast. When a router updates several connected devices at once, that's multicast. And when an ARP request looks for a device's MAC address, that's broadcast. All these rules work together to make communication reliable, efficient, and predictable. Just like how people follow grammar when speaking, computers follow these networking rules to understand each other.